Alright, so as we were just saying, for that problem on your homework, number 11, whoops, wrong one, this guy. The only way we could have solved for x based upon the information you knew before today was to set up our sign, simplify the 24 over 29, and then look on our chart to see the value that was closest to it. From there, we saw our closest value was 56 degrees. But sometimes I want the exact angle and not just a rounded measure of it. So that's what we're going to do today with our notes. Okay, so let's first start off reviewing what sine, cosine, and tangent are. So we have sine of x, we said is opposite over hypotenuse. It's supposed to be a y. Cosine of x equals adjacent over hypotenuse. And tangent of x is opposite over adjacent. Again, these values change based upon the degree you're dealing with. So you must specify which degree you're working with. You must specify what you're taking sine, cosine, and tangent. So I'm just going to make up a problem. Say that I had this. X is my angle there. And let's do example. Okay, so go ahead and draw on this example. Alright. So sine of x equals opposite over hypotenuse. Sine this up to find our x value there. We have sine of x equals, what's my opposite side? 8. What's my hypotenuse? Oh, what did I do? What mistake did I make? Right now, sine is about ready to pass out because there's no x.
Right there, Miss Marva.
Are you the little degree or not?
I'm not thinking about that. I'm not thinking if you put the degree or not. Because for geometry, we'll always deal with degrees and not radians. Alright, so it was what, 8 over 10?
Shouldn't we need to learn to do it the right way? Because then next year, when we're dealing with radians, we're going to be writing something else.
Right.
And if we don't write it at all, we'll get points taken off.
You better put the degrees then.
Mm-hmm.
Okay. Alright. So again, if we were to go ahead and divide this, what's 8 divided by 10?
0.8.
Look on our chart. We're dealing with sine. Where's sine closest to 0.8?
54.
Is it 54 or 53?
54. 53. 53. 53. It's 53!
I'm thinking 53.
But aren't you supposed to round up?
We're not
What is it
we are
closest
rounding
to?
up anyway.
What, 0. If it's 0.8,
We're rounding up.
yeah, you should be rounding up. Because in elementary school, they always told us to round up.
Only if it's 0.5.
But I think it is. It's like 0.9.
Why is she doing it 14? Yeah, we are.
Yeah.
And then the other one is like.
So I'm finding exactly how far away it is from each one. So this is, I want to show you first how to use it with the table, and then how to do it with the calculator. I'm going to show you why the calculator is more accurate.
It's more, the other one's like 0.09. Or it's 0.009.
Whoops.
No, it's
Whoops.
0.009 this one. Get out.
Alright, so here's the issue we run into. It's pretty close to the middle, right? So the question is it 53 or is it 54?
53.
Now here's the tricky thing. Sine, cosine, and tangent are not linear functions, meaning that it does not increase the same amount each time. So just because it's closer to 54 doesn't necessarily mean that it's the 54 degrees.
It's closer to 53. Oh my god.
No. Didn't I offer you a chip? You can have a chip.
I don't like salty.
Sorry.
I like salty also.
Alright. So on our table, we're always approximating, right?
Yeah.
But if I want the exact value, or if it falls pretty close in between, like say we had 0.799. We know it's definitely going to be 53 degrees. But it's pretty close in the middle, we're not sure which one it is. So what we have to do is we need to get x by itself. So let's go back to some of the basics of algebra. You don't have to write this next part down. In order to get x by itself, what would I need to do? Square root. You're doing it on purpose. The opposite of squaring is square root, right? Those cancel each other out and we're left with just our answer. What if I had this? What would we do? We would divide. The opposite of multiplying is to divide, right?
Wait, why are we doing this?
I'm trying to, you don't have to write this here.
Oh. Wait, why are we doing
I'm trying to show you why we're about to do the next piece.
But you didn't say what it was closer to here.
I know, I'm trying to get there. Hold your horses. Alright, so we have to do the opposite operation, the inverse operation, so that the operations cancel each other out and we're left with just x. So similar thing here. Sine, cosine, and tangent are operations. Operations are where you do something to the number. So to get x by itself, what we have to do is actually what's called inverse sine. The inverse operation, the opposite, the only way to undo sine is to do inverse sine. So what we have is x degrees equals inverse sine, which is represented with a -1 up in the superscript of 0.8.
You gotta straighten it out to get the blood flow going. Isn't it bad?
Alright, so again, to solve for x, which is what we're trying to do here, in order to undo sine, I have to do inverse sine. Now what we're technically doing, I'm not making you write this part out, but what we are technically doing is from sine of x equal to 0.8, what I'm doing is taking the inverse sine of both sides, and inverse sine cancels out my sine, leaving me with just x equals inverse sine of 0.8. Stop talking while I'm talking, I can explain it. I am trying to explain to you what we just did.
Do we have to do it like that? No, you just gotta kind of.
Please, listen, stop talking while I'm talking.
Guys, we need to be quiet and respectful.
She's right. Alright, so everyone stop talking and listen. This is not bad, I guarantee you. Right now, we have sine of x equals 0.8. The only way to get x by itself is to get rid of your sine. Sine is an operation. I cannot just divide by sine. Sine is an operation. If I said divide by sine, that's like saying, oh, divide by square root, divide by absolute value, divide by plus. You can't just divide by an operation. You have to divide by a sine of something, or you have to divide by square root of something. So dividing by sine would not get rid of your sine. The only way to undo a sine is to do the inverse sine. Just like the only way to undo square root is to square it. The only way to undo a cube is to cube root it. The only way to undo a sine is to do the inverse sine. Now, what we are technically doing, and this part you do not have to do each time, but I'm trying to show you why we're allowed to do what we just did. what you are technically doing is taking inverse sine of both sides. Because what you do to one side, you must do to the other to keep it equal. I cannot inverse sine just one side without inversing sine the other. When I take the inverse sine of sine, that's like taking the square root of squared. They cancel each other out. Taking the inverse sine of sine is like dividing when you are multiplying. They cancel each other out. So you're left with x on this side and inverse sine of 0.8 on this side, which is what we have here. Yes, sir.
With any other value, you know, with like the negative exponent, wouldn't it be like under the 1 for like the...
So
Yeah, so that's like dividing by sign.
no. Be careful. This does not mean sine to the negative first power. This means inverse sine. If you do 1 over sine, that's called cosecant. That's something you learn about in pre-calc. Okay. So this notation here, this notation is not an exponent. This notation means inverse sine, which means the opposite.
Wait, why do we move the notice?
This allows us to get our angle by itself.
But then,
What's like the value?
how do you do that? Yeah, what's the value of
Thank
sine?
you! Can we finally get to the value now?
No, but that doesn't make sense. How do you, what's the value? It's like sine, does that mean like sine, the inverse of sine times 0.8?
No. Guys, sine is not a number. Sine is an operation.
So,
Just
the
like
inverse-
square root of 3 is not square root times 3, it's square root of 3.
So it's like 0.8
So sine,
inverse of sine.
sine of a value, means what we are doing is
The opposite divided by the hypotenuse.
finding the ratio of the opposite over the hypotenuse.
So we have to 0.8 times the hypotenuse, the operation divided by the hypotenuse.
Guys, please stop talking while I'm talking again. Sine, the operation of sine is saying for this specific angle, the ratio of the opposite side to the hypotenuse. Inverse sine then is going backwards. Inverse sine says, hey, I gave you the ratio. Now tell me what angle gives you that ratio. Over here, hey, I gave you the angle. Tell me the ratio that goes with that angle. So here I'm finding my angle before we were finding the side. So inverse sine says, here's my ratio. What angle goes with that ratio? Because for sine of 30 degrees, every single 30 degrees that you find in a right triangle will have the same ratio every single time. So we need to figure out what angle goes with 0.8 as your ratio. Or your opposite of hypotenuse gives you 0.8. Yes, Dan?
What's the nature of sine? Like, you know, addition combines two values to make usually a larger value. But what is the nature of the operation?
So that's what sine, cosine, tangent are. Sine, cosine, and tangent are finding the ratio of the sides of a given angle. Addition is taking two values, combining them together to give you a larger value. Sine is taking an angle, finding the ratio of the opposite side to the hypotenuse for that specific angle. Same with cosine, just different sides. Okay, so inverse sine is just a function on your calculator. What we did before was we found where 0.8 was on our chart, and we did the act of inverse sine. We found our ratio and went back to the angle. Well, now we can have our calculator do it for us to give us the actual value. So if you look in your calculator, we have sine, cosine, and tangent, and look at what's above there. Inverse sine,
What?
inverse cosine, and inverse tangent.
You let me smoke out. Click on it.
So let's do inverse sine of 0.8. We're trying to figure out what degree goes with the ratio of 0.8. What degree that every single time we look at the opposite side to the hypotenuse side will give me 0.8. So I do
Second
inverse sine, which is second sine, 0.8.
8.
That means for angle of 53.1301023 degrees, every single time will have 0.8.
That's what we said anyway. So.
Yeah, so I showed you first how to do it on the chart. I'm showing you the calculator. So the calculator gives you that exact value, whereas the chart you'd have to estimate. Okay? So our final answer here would be x is approximately 53.130 degrees. All right, so again, we have the possibility of 0 to 90, well, a little bit above 0 to a little bit less than 90 degrees for a triangle, right? My other two angles must add up to be 90 degrees. So my answer should be somewhere between a little bit above 0 to a little bit less than 90, between 0 and 90, not including those values. Every single angle measurement has a specific sine value associated with it. Sine of 30 degrees every single time, sine of 30 degrees every single time will reduce down to square root of 3/2. Sine of 60 degrees every single time will reduce down to 1/2. Tangent of 45 degrees every single time will reduce down to square root of 2/2. So every single angle has one specific ratio that goes with it. I'm not making those words up, I promise you. So sine of every single 30 degrees, no matter how large or small your triangle is, this is 30 degrees, your other one will be 60. Every single time, even if we enlarge a triangle ginormously, the opposite of our hypotenuse will reduce down to the same value every single time. That's because we're dealing with similar triangles, right? Similar triangles, the ratio always reduces down to the same value. Same thing here. Okay, questions with that?
Wait, what's the sine of?
Yes, sir.
You can just type in the second sine 8/10, right?
Yes. So I made you walk through every little bit of this, but we could have from the very beginning just done inverse sine of 8/10, which is what we will be doing from here on out. Okay, now I want to show you what it is for cosine and sine, or sorry, cosine and tangent. So let's set it up for these. For this particular problem, cosine of x equals what? Good, 6/10. So x is going to be inverse cosine of 6/10. Okay? The only way to get x by itself is to do the inverse cosine of both sides. Now tangent. If I set up tangent, tangent of x equals what? 8/6. Good. So then x has to be the inverse tangent of 8/6. The only way to get x by itself is to do the inverse of both sides. So I want you to put these in your calculator. Do inverse cosine of 6/10 and do inverse tangent of 8/6. What do we get? Good. You should have gotten the same thing for every single one. Why is that? Is it what, Cynthia? Yeah, we're finding the same x each time, guys. We're doing the same x. We're solving for the same x each time. So you don't have to do all three trig functions. But I wanted to show you that sine of x, well, if you do inverse sine, you'll get the same thing as if you do inverse cosine as if you do inverse tangent. We're solving for the exact same x each time. Okay, so you don't have to do all three, but I wanted to show you that all three would yield the same answer. This sine, cosine, and tangent only works for which kind of triangles? Right triangles. Okay, questions on that? Okay, let's do a couple together. Let's scoot down to where we have some more room. Let's try this guy. All right. Now, they didn't give us the hypotenuse, so what could we do to find the hypotenuse? Pythagorean theorem. But do we really need to?
No.
What could we do instead?
Wait, which angle?
Yeah, just use tangent. We have to find angle A and angle B. Well, if I do tangent of angle A, what would that be equal to?
6
Okay, 6/5. So then A would have to be the inverse tangent of that. And what would that give us?
It's pretty simple now. So we find the angle so quickly.
50.194. Alright, so we found A. Now let's find B. Again, we can use tangent, right? We still have opposite and adjacent. So tangent of B would be 5/6. So then B is the inverse tangent, 5/6. Alright, so what is B approximately? 39.06.
39.80.
Sorry, 806. Thank you. What do we notice about these two values? What happens if we add them together? They should be approximately 90, right? Which should be true. These should be complementary. And that's all you have to do. Boom, we just found both angles. Okay. So you don't need to use your table. You can if you want to. But with using your table, you run the risk of going to the wrong angle. So I would recommend you use triangles. Questions on this? Yes, Jesse?
Oh,
So here's my angle. Opposite over adjacent. So opposite of A is 6. Adjacent is 5. Tangent is opposite and adjacent. But notice for B, we have a different opposite and a different adjacent.
so you either use sine, cosine, or tangent for different circumstances that you have with it.
Yes. So Kay just said something very important. You will use either sine, cosine, or tangent based upon what values you have. So different circumstances, you use different ones. Here, I had the opposite and adjacent, so I could use tangent for A. For B, I had opposite and adjacent, so I could use the tangent for B. If I look at number 2, for B, I have adjacent and hypotenuse, whereas for A, that's opposite and hypotenuse. So you would change your trig function based upon what values you have. Okay. Questions on that? Does it seem a little bit better than when we first started it? It's not actually that bad. Yes, Tiffany? It depends on what angle you're dealing with. Say we're dealing with angle A. This is my angle. The side opposite of that is the one that's not even making that angle at all.
Wait, what is the one you're finding?
Cross from it.
What if your opposite one is the hypotenuse?
Then you're dealing with 90 degrees. We don't ever find the 90
Okay.
degrees.
Oh yeah, sure.
And then Tiffany, adjacent is going to be what's connecting to it. So your hypotenuse is always what's across from your 90 degrees. So this is my hypotenuse. Your adjacent is the side connecting it. That is not your hypotenuse. Alright, questions on that? Okay, flip it to the back side. Let's talk about angles of elevation and angles of depression. Alright, so you've already been dealing with word problems. They just did not use the term angle of elevation, angle of depression. But these are common phrases to use when we're dealing with solving for an unknown side or solving for an unknown angle. Angle of elevation is when we are looking up. It's the increase or the rise angle. So going up, that's your angle of elevation. Now, if you're at a parallel line looking down, that's your angle of depression. So that's going down. All right. So from this point here, say we're talking about point A. The angle of elevation from point A would be going up. Angle of depression from the top of the building is going down. From over here, from this little stick figure guy, the angle of elevation to the plane is from his eyes looking up. The angle of depression from the plane down would be this here. So this is my angle of depression.
Doesn't it just change every single time you like look at it? If you look at it differently?
Maybe hold that thought for a second. What is true about my angle of elevation, my angle of depression? They're equal. Because what we're dealing with here is parallel lines. For these problems, we're going to assume that the floor is flat, that the earth is flat, even though we know it's round, but relatively speaking flat. And our angle of depression line is going to be parallel. Because these are parallel, these are alternate to your angles, meaning that these are equal. So these are actually equal. Okay? Right, so they go with the parallel line. It's what we call an auxiliary line, the line that's drawn like that. So let's take a look at our example here that they walked through with us. It says the angle of elevation, meaning we're going to be going up, from point A to the top of the cliff is 38 degrees. So here's point A, here's my cliff. Angle of elevation is from A going up, so 38 degrees is this right here. They tell us that point A is 80 feet from the base of the cliff, and they want to know how tall is the cliff. Okay. So you've already been doing problems with this, they just didn't use that terminology of elevation and depression. So here we see that from 38 degrees, we have our opposite side and our adjacent. So that means I would use tangent. Tangent of 38 degrees is equal to my opposite side, x, over my adjacent side, 80. Again, you've already done problems like these, such as the ramp on the back of the moving truck, or the ladder up against the wall. They just use different terminology to tell you the degrees. Okay. Then we would multiply by 80 on both sides, and we get x is approximately 62.503 feet. That's what's right. Well, it's because they actually already did it for us right here. I didn't have that one. All right, so let's take a look at number 1. Let's just set up the problem. It says from the top of a tower, here's my tower, the angle of depression to a stake on the ground is 72 degrees. So the angle of depression, here's my stake on the ground, this guy is 72 degrees. So angle of depression is looking from the tower down to that stake. The top of the tower is 80 feet above ground, so I know this height is 80. And how far is the stake from the foot of the tower? So I'm trying to find x. So again, the tower is 80 feet tall, and we're trying to find how far away this is. Okay, well, if my angle of depression is 72 degrees, what does this measure right here? 72 degrees. All right, then you could set up again using one of your trig functions. I have my opposite side and my adjacent. So tangent of 72 degrees is equal to my opposite over adjacent. It's not holding up the building. They're saying you're at the top of the building looking down to the stake on the ground. This is the eyesight line of eyesight. Okay, then you would solve for x for that. So angle of elevation, angle of depression, is simply talking about the frame of reference at which you're looking at. Yes.
Why would the angle of depression not be the one on the inside?
Because angle of depression is defined as the what's it called? Parallel line looking down. Alright, so your homework is worksheet 4 and 5, as well as some bookwork problems. 4 and 5 is here. Bookwork, make sure you look at your assignment sheet. Feel free to take a snapshot of the page. Alright, so again, your homework is worksheet 4 and 5 as well as the bookwork. If you notice on your assignment sheet, we do have a quiz next class / next class's review. So we'll review a bunch first, and then you will take your quiz. Your test is on Friday. Alright, so then we multiply both sides by x. That cancels out over here. So I have x times tangent of 72 degrees equals 80. And then to get x by itself, I have to divide by tangent of 72. Remember, you should never be dividing by just tangent. All right, so divide by tangent of 72 on both sides. Make sure your calculator is in degrees. And then I have x equals 80 over tangent of 72. Let's figure out what that actually is. 80 divided by tangent of 72. All right, and let's see. I didn't specify how much to round to, so we go to 3 decimal places. So 25.99, and what was that last number? 25.994. And we are dealing with, let's see, feet. Okay. So again, your homework is worksheet 4 and 5, as well as some of the bookwork. Next class is quiz 2 and review. So we'll probably spend the first chunk of time reviewing, then take the quiz, then finish with more review. Your test is on Friday.